Hello, welcome back for the video for lesson 4.4. We have moved into exponential function and its inverse function, which is the logarithmic function. And now we're going to learn about properties of logarithms and what we can do with them mathematically. So the product property of logarithms says that the logarithm of a value that you can break into products of two to multiple numbers then can be split into the addition of their separated logarithms. So example one, I'm giving you here, it says, given that log of 2.5 is approximately 0.3979, and then this log of 3, which we actually really don't need, calculate the log of 2,500 without using a calculator, and then check the answer with the calculator. So we can write the log of 2,500 can also be written as the log of 2.5 times 1,000. So anything that can be a multiple of 10 is kind of a freebie. And so that's why I said 2,500 divided by 1,000 gives me the 2.5. So then I can use the 2.5. Then we can break them apart and say log of 2.5 plus log of 1,000. Now we know that they gave us log of 2.5 is approximated to be 0.3979. And then log of 1,000 off to the side here. Remember, log is a natural log of 10. So this is the same as saying 10 to the what value gives me 1,000. And that is when x equals 3. So the log of 1,000 is 3. So the answer to the log of 2,500 should be approximately 3.3979. And I'm going to go to Desmos and we're going to check it out. There it is. Okay. Now we're going to look at the power property of logarithms. The power property says, as long as x is greater than 0, a is greater than 0, and a is not equal to 1, then if we take the log base a of x that is raised to some power, we can really just bring that power out front and multiply by the log. And so example 2 is asking us to simplify. So there's more than one just power thing going on here. There's also a product that we can use. So first I'm going to rewrite this the square root of y as y to the 1/2. So we've got actually x is to a power and y is to a power. And we've got the product of these three things. So we're going to separate those first. So the log of 4 plus the log of x to the negative 1/3 plus the log of y to the 1/2. Then we can bring the powers down out in front. So this is really the log of 4 minus 1/3 times the log of just x plus 1/2 times the log of y. So you can bring the power down in front. We also have the quotient property of logarithms. And the quotient property says that if you have the quotient of a value that can be brought, can be separated into a fraction or a quotient of two numbers, we can actually just break apart those logs of the difference of their separate individual logs. So I'm just going to give you a side example. If we said the natural log of 20, we could really rewrite that as the natural log of 10/2. And then we could write that as a log of 10 minus the log of 2, if we wanted to do that. Okay, so let's do that. Example 3 says, write the log of the square root of x minus 1 over x squared plus 4 as a sum and or difference of logarithmic expressions. So we have several things going on here. First thing I'm going to do is I'm going to rewrite this as x minus 1 to the 1/2. And then I've got x squared plus 4. So I'm going to separate the numerator and denominator first. And so I separated that by a subtraction. And then my log of x minus 1 to the 1/2, I can bring my 1/2 out front. I can't split up this x minus 1. And I can't split up this x squared plus 4. So this is what I'm left with. But it is going to help us that we can break apart products of logarithms and quotients of logarithms. Okay, now example 4 in letter D is just combining logarithmic expressions. So we're going to go the opposite direction. We've got two separate logarithms and we want to write them as a single quantity logarithm. So because we have the subtraction, that tells me it is going to be turned into a quotient or a fraction. So I'm going to do that first. And we can do that also. They have to be the same base. So they are both base A. So this. And then that 3, because it's out in front, it really gets rewritten as an exponent. So this is really the log of x cubed over x squared plus 1. And it's log base A. We have to make sure that we acknowledge that it's a base A here. And the last one is just a little applications of logarithms. The pH of a solution is a measure of concentration of hydrogen ions in the solution. This concentration, which is denoted by H plus, is given in units of moles per liter, where 1 mole is 6.02 times 10 to the 23 molecules. Because the concentration of hydrogen ions can vary by several powers of 10 from one solution to another, the pH scale was introduced to express the concentration in more accessible terms. So we can find the pH of any liquid by taking the negative log of the H plus, if we know the concentration. So it says find the pH of a solution whose hydrogen ion concentration is 3.2 times 10 to the negative 8 moles per liter. So we're going to find the pH by taking the negative log of this number. So you can do find the pH of like milk and water. Milk is basic, but if you do like a pickle juice, that's going to be acidic. So let's go to Desmos to do this. So we're going to put in a negative log and then parentheses times 10 to the negative 8. So this liquid, whatever it is, has a pH of 7.49. Catch me back for another video.